long division doing 6 into 25. So if you want to get specific, I'm about to show you solve a simpler problem, right? One of my favorite damn things to do. This problem sucks because there's freaking variables all over the damn place, right? That's why it sucks. If we look at a concrete problem,
I think it's the remainder that was throwing me
I know. So if you look at 6 into 25, how many times does it go in? 4. Remainder? 1. Okay. What is 6 times 4? Is it equal to 25?
No.
No, it's equal to 25
Plus 1.
No. All right, let's do this. 6 times 4 is
24.
24. So when I add 1 to it, I'll
Okay.
get 25. This is cool. So 6 times 4 is equal to 25 minus 1. The remainder is always how much extra did the number have that took away from something I could go into evenly. 25 is 1 bigger than I would want it to be because then 6 could go in evenly. Does that make sense?
And in that case, C is 20.
Yeah, so what is the problem again? I'm sorry.
25 divided by C.
Oh, 25 divided by C is,
Wait, C.
Divided by 25.
I love you guys. Whatever's inside is what I'm dividing into.
Okay.
So there's a C in here?
Yes.
Alright, and then dividing by 25.
Yes.
Yes, and I'm getting B
C.
22, right?
Yeah.
Like that? Is that right? Okay. I should have just looked at the paper.
Plus 22 is equal.
So, real quick, just to make sure you guys are all cool with this. This would be C divided by 25, correct?
Yeah.
Okay. So, looking at what we just did, 6 times 4 plus 1 is 25, correct? So can you write something similar here? What must 25 times B? It's almost equal to C
Plus B plus 22.
plus 22. That gives me C. Let me stop for a minute. And you're not supposed to just look at that, no. So it's a good idea to do a concrete example for yourself. This is exactly why we talked about the solve a simple problem. Just like I told you, if I have too many variables, I'm gonna give some numbers to them, let my brain go, okay, that's what, and they go, oh, okay, that's what I'm gonna do with the letters. So if you give yourself another example, 7 into 40 goes how many times? 5 times. With what remainder? 5. So 5 times 7 plus 5 is 40. That's what that means. The remainder is how much the product needs to help it become fully this number. That's what a remainder is. Another way to look at it is how much bigger is this than something that can go into evenly. So then 25 times B plus 22 makes C. Now what is it I'm asking for? You're not done yet.
Compute for the following division problem.
Compute what?
25 times B.
So how do I get 25 times B by itself?
Subtract 22.
Yeah, subtract 22. So the 25 times B is C minus 22. The same way that 7 times 5 is 40 minus 5, yes? The same way that 6 times 4 is 25 minus 1, yes? Same way. So feel completely free. If there's too many variables in a problem, just replace some of them with numbers. Variables are just numbers we don't know yet, so they have to act like numbers. So if I just give myself some numbers, I'm not cheating, I'm solving a simpler problem. It's a method to get to know a problem. And when there's a lot of freaking letters rolling around, you go, holy shit, let me give myself an easier problem. Yes? No? Maybe?
Wait, so that's it?
Huh?
So that's it?
Yeah.
Wow, I really.
Yeah. Is that not enough? I'm sorry. I can make it worse. Wow, people didn't immediately say no. Interesting. All right. All right. I know what kind of problem I'm going to make. I am joking. Everybody calm down. All right. So again, it's wide open. If there are problems from the homework that you still have a deep hatred for,
Yes.
we can look at them. or mild annoyance. You don't have to have a deep hatred.
Practice test, do you buy the test? Or is it just a practice?
I'm gonna give you the answer key today. You don't have to even look at the price. You could have immediately made a little paper airplane out of it, flown it somewhere, right? It's just an extra study guide. If you do all the homework, then you should be ready for the test. The practice test is just kind of a nice, it kind of shows you how I'm gonna set it up, blah, blah, blah. Yeah.
Number 6.
Yes.
So it says student writes 3 times, writes these 4 times 5 plus points equals that.
Yeah. Now, real quick, just to let you know, I've seen that so many times teaching college. And so, you all know all too well. In fact, some of us in here don't like fractions. We have trouble with fractions. So I have students in the highest level of math that we teach here that has troubles with fractions, right? I mean, it's just ubiquitous. It's everywhere. So I see that a lot, exactly that problem. So what did they misinterpret? What property did they use that really doesn't belong for that problem? So let me write it up here. Let's see. What was it? 3 times 4 times 5, right? Yeah. Oh. 3 times 5, is that right?
Yeah.
Good job. Pass, Jeff. Okay. What property does it look like they try to use that they shouldn't have? Distribution. I love it. What is one change you could make to this problem that would make distribution actually valid? So, yeah, sorry.
Multiplication mark that's outside of the.
If I change this to no, if I change this to plus, because distribution is specifically multiplication distributes across addition or subtraction. So if it was this, then this would make all the sense in the world. Because I have 3 4s and I have 3 5s. Does anyone have a way, what did it say you explained to them? What did it say?
Yeah.
What would you say to the student? Sorry. Sometimes I get somebody that has no idea, they just write something like, I just tell them, holy crap, I don't know. Get a calculator. I'm curious, what would you say? These kind of problems have 2 levels. You need to fully understand yourself what the issue is, and then you have to figure out how to communicate to the student, correct? And that's going to be your daily life. Figuring out what the problem is and figuring out how to explain why it's a problem. Yeah.
I put, no, you are multiplying the product of 4 and 5 by 3, not 3 by each number, then multiplying.
But that doesn't explain why I can't do it.
Is it that you can't do it, or is that he's wrong?
Yes. You cannot do it because it leads to an incorrect answer.
Fair.
Yeah.
But I'm. Okay.
There's a really, just tell me this, how would you do that problem? What's the correct way to do the problem? That's not good enough for an explanation. An explanation should never just stop at, here's the way to do it.
So
You need to incorporate the mistake the student made so they can really see why it was a mistake. Go ahead.
And it would be, you do the 4 times the 5 to get the 20, and then you do 3 times 20 to get 60?
Sure. Yeah. In fact, you got to do it that way. You know PEMDAS, right?
Yeah.
And just to remind you guys, you don't have to do it that way, but you can't do it this way for sure. One way you could do this, because this I could do 4 plus 5 is 9 and then times 3, but also distribution will work. Either way will work. Agree with me so far? So let me ask you a really silly question. How many 3s are in that product? How many 3s are in that product? What numbers are multiplying? Somebody tell me. What numbers am I multiplying? 3, 4, and 5. How many 3s are in that product? How many 3s? 1. There's 1 3, 1 4, 1 5, correct? How many 3s are over here?
2.
Okay, how the shit did you, do you see what I mean? There's only 1 3. How would the 4 and the 5 each get a 3 then? Then you got to really understand why this works. Right? So let me show you this. Why does this work? Stay with me. What does 3 times something mean?
3 groups have said something.
Yes, so if I have 3 times 4 plus, I got a 4 plus 5, I have another 4 plus 5, and I have another 4 plus 5, and of course multiplication is based on addition, correct? Is everybody with me?
Yeah.
That's why I can do 3 times 4, because I get 3 fourths, right? And I can do 3 plus 3 times 5, because I get 3 fives. So I could distribute, is everybody with me? So up here, multiplication means I have 3 of these, but what am I doing? Multiplication is based on what operation? What's 3x? X plus x plus it's based on addition. It's repeated addition. That's the most fundamental definition of multiplication. Is it's repeated addition, right? You guys with me? So if I rewrite this, what do I have 3 of? I have 3 4 times 5s. Do you guys see that? That doesn't lead to this. The quickest way, and this is how I tell a student that something's gone wrong, it's just the fact there's only 1 3 here. How do I now have 2 3s? So real quick, somebody could say the same thing here, but I can't put these together. What is 3 times 3? 9. So now I have 9 times 4 times 5, right? Do you guys see what I'm saying? Could I do it again then? And now I could do 9 times 4 times 9 times 5. When would it stop? Are you guys at all with me? For me, and I'm really always curious, these kind of questions, I'm always curious the way that you look at them, because one thing as a teacher you want to do is you want to try to get as many perspectives as you can. Whenever you start to teach a new class, you want to get with everybody else who's ever taught that class and say, give me some worksheets, give me some handouts, give me some ideas. How do you introduce this? You need fresh perspectives. Because the hardest thing about being a teacher is trying to come up with a way to explain something you've already explained. You just have to come up with a different way, right? To me, when I say there's just one factor of 3 and now you have 2, that's it, right? You guys got it with me. If I reorganize this like I just did, I'll get this, yes? And you can very easily see that these cannot be the same, yes? So any combination of those I would accept. Did anybody answer that question differently on the practice test?
I didn't, but is there, if you look at it a way, it's also a substitute property, and you do.
Oh, yeah, that's basically what I'm using here, but how would you do it?
So you explain it where, what if you, since it's multiplication and it applies associative property, you can do 3 times 4 in parentheses instead of 4 times 5.
Yeah, like, okay, so you can rewrite this like this, yeah?
So then that completely changes it to, if you were to use distributive property, would be 5 times.
Now the 5 would go, and it really wouldn't be the same as that, yeah, okay. There's a few different ways you can go. You guys doing all right? Those questions are always the hardest questions. Because number one, you don't know what you want from me. And the reason it's really hard is because I don't know what I want from me either. I need you, whatever you think. So it's always 2 levels. You need to understand it yourself. Well, it's actually 3. You need to understand it yourself. You need to see what the mistake was, and you need to be able to explain what that mistake was, right? So I have an answer that I would think of. But I'm always curious, what would you guys say? So when I ask you, how would you explain this to the student? Write as if you are talking to that student, right? Because a few of you guys just kind of like give me a couple like, yeah, well, actually it's this. No, if you said that to a student, do you think that would be enough? And I know you don't, you just don't, you gotta put yourself in the mindset. You are talking to the student when you're writing the answer, okay. Is that all right? Hopefully everybody understands that was a mistake that was made. What about number 7? We've kind of talked about that a few times. I think we all should kind of know a way to explain that, yeah?
Yeah, I put the no, I'm confused where you got another 3 from, and then like do the picture of all the 3s.
Yeah. So of course, I have an easier job because I talk to other adults. so I can kind of talk to them a little more bluntly, and sometimes with colorful language, as you've experienced. You're not going to be able to do that as much. So when I say, I don't know where the hell you got this other 3 from, you probably don't want to say that. But I get what you mean. Does anyone else have another way to answer number 7? Yeah. No? Do you have another question?
Yeah.
Okay. Are we all okay with number 7? The quickest way to do it is to write 2 3s, 3 3s, and then have them count, right? And I don't know if it makes sense when I say there is no 2 and there is no, right? There's no 2 anywhere in that whole thing. There's no 2. There's no 2. Is everybody with me on that? I'm always curious if somebody thinks, man, this guy is off. There's a 2 right there. No. That just means there's 2 3s. There are no 2s. So that's another thing to kind of get across to students. The exponents are just keeping track of how many 3s I've got. So there's no 2 to multiply by 3. There's 2 3s, 3 3s, 5 3s. End of story. I love it. You guys with me? What would I have to do with a square and a cube to make the answer a 6th power? That's a really weird question, but I'm going to stand by it. I can't do it by multiplication, correct?
3 squared to the 3rd.
Yeah, 3 squared to the 3rd power, right? If I do 3 squared to the 3rd power, what's anything to the 3rd power? What do I do with it? What does that mean? If I ask you to do 12 to the 3rd power by hand, what would you write down? 12 times 12. Okay, so I got this to the 3rd power. And then what do you do with powers when you multiply like bases? Add, right. So you don't do this. The shortcut is the definition of multiplication. 3 groups of 2 is 6. That's the definition of multiplication. Yeah. Can't remember. All right, I'm sorry. Did you have another question?
Yeah. Number 9, it's asking to find a range.
Oh yeah. So, whenever I ask you to find a range estimate, or just a range, you take everything down, as far as down to the next whole number below them, right? That'll definitely be low. So if you force every number involved down, the answer you get is going to be way lower than it should be. If you force every number involved in the multiplication up, the answer is going to be way bigger than it's supposed to be. So then you'll get a range from low to high. So what does that look like? If you round the first number down, what do you get? What's the first number?
860.
Round it down to the next round number below that.
800.
800. And if you round the next one down, what would it be? 500. Everybody agree with me, this is very obviously going to be way below what it's supposed to be. So it is very obviously a low estimate. Then I'm going to make a high estimate, right? That doesn't mean make it an estimate while you're high. So I'm going to take this, I'm going to go up instead. Good, I guess. And I'm going to make this one go up instead. Is that all right? So how do you multiply this easily? What's 8 times 5? 40. And then I want 1, 2, 3, 4. Do the same thing with the other one. You'll get low and high. In class, we talked about if I take those 2 numbers and average them, I actually get a decent direct estimate. But I was also talking with some students earlier. If I'm trying to estimate how much money I'm going to get from some job, to be conservative, I might go with the low estimate. If I'm trying to estimate how many people are going to show up for some concert, I'm going to be conservative and go with the high estimate so I get enough chairs. Does that make sense? So there are physical, real-life, everyday examples of why you want to know a range for the possibilities. Yes?
12 on the practice test.
Oh, yeah.
What's the coefficients again?
So when you have subtraction, it's all about distance. So if I add or subtract the same amount from both numbers involved, the distance apart will be the same.
Oh, so you.
So there's 2 ways to do that problem. Yeah.
Oh,
I have the rest of the practice test.
Oh, sure.
Thanks.
So you just,
I don't know.
what you do to add on one.
You got my
side, add to the
email?
other one.
Because I was trying to warn people that got it early. There's just a few I added at the end. The actual test, probably won't be quite as long as this, but we'll see. So I'm sorry, number,
Number 12, you just, what you add on one side, you add to the other. You're only worrying about how many numbers apart they are.
yeah.
Okay.
So if you add the same amount to both, you're not gonna change the answer. 7 minus 5 is the same thing as 8 minus 6, right? So on one level, it feels like you're cheating, but when you realize what subtraction wants from us, there's flexibility in how to get the same damn answer. So there's two ways to do this. What number would this be better to be?
30.
30. So how much do I have to add to him?
2.
So I better add 2 to him, and I get
202.
203. What number would this be better?
230, yeah.
I would like it to be 229 actually, and then if I do minus 26, I still get 203. I'd rather do that. It's easier if the second guy's a nice whole number. You guys with me? If I go up 2 for both or down 2 for both, the subtraction doesn't give a shit. It's like, whatever you want to do, human. It's still the same distance, right? Okay. I love you guys. So real quick, I don't make you ever answer a definition question, but what does something like compensation mean? Could you show me an example problem that involves compensation? I want somebody to go, are we getting paid? Shut up. No, not that. What's an example problem that would involve compensation?
I'm nervous. I feel like,
You're fine.
for example, like you could do like 9 plus 11, you just make it 10%.
Yeah, I love it. There's a very straightforward example. I love it. So if you have 9 plus 11, which could be very, very difficult for some students just learning stuff. If you take 1 away from him and give it to him, now 10 plus 10 is relatively easy because we're talking about the fact that the doubling is something we pick up pretty quickly, right, for example. So compensation just means, it could be additive compensation, it could be multiplicative. I just take a part of one number and give it to the other one, which is what compensation is. If you work for me, if you mow a lawn, I'm gonna take money away from me and I'm gonna give it to you. That's why we call it compensation. I like it. Is that all right? What about compatible numbers? If I have a string of numbers to add, what do I look for? Like if I had to add 4 plus 11 plus 17 plus 29 plus 16 plus 13, what am I looking for? Like what does 4 go with nice?
6.
Ah, those are compatible. Hey, you know what compatible our numbers are. So a lot of times it's a process that we just naturally do, and we don't necessarily know what the hell it's called. Yes? Same thing with your students. I don't care if a student knows the word compatible. I don't give a shit. I just care, does it make sense to do this, right? And they're gonna naturally want to do this kind of thing. 11 would go with 29, and 17 would go with 13. So in fact, that's kind of like an approach I used to take when we were allowed to teach algebra, is I would find like terms using similar weird underlinings. Yeah. Instead of actually rewriting the whole damn thing. You guys with me? So if I say use compensation to solve this or simplify this, that's what I mean. If I use compatible numbers, this here is what I mean, right? As you guys have noticed, very often the homework gets a lot deeper than what I put on my test, and that's on purpose. Most homework goes a little bit beyond what you're going to be tested on, because homework is supposed to push you a bit, because that's where you have a bit of a safety net. You can get help with the homework, right? You can't get help with the test. At least not at first.
For the homework, I mean, can we go over a question for the homework?
Yeah, it's wide open.
24, chapter 3.2A 24. It's the magic box.
Oh, yeah. What's the box? 32A24. Oh, yeah. Alright, so, most magic squares or magic whatever, they involve the same idea. They've already filled some spots in for you, right? But they want me to use the numbers 1 through 9, is that right?
Yes, it's a 9-box box.
And I'm supposed to get it so that it adds up to be the same no matter which way I kind of look at it, correct? Remember Gauss and his weird shit? You guys remember Gauss when he was a little dude and he had to add the numbers from 1 to 100? Something very similar happens here. What is 1 plus 5 plus 9? 15. What is 2 plus 5 plus 8?
15.
15. So it kind of makes sense. If they're supposed to add up to be the same thing, what do I want to put in the middle of the picture is the number that's in the middle of the numbers. Because as I move in towards it from both sides, I can make the sum the same. If I make this number go up 1 and this number go down 1 and they're both adding to 5, I'm going to get the same sum. Does that make sense? So that's one of the ones they already gave me. They already gave me 5 in the middle, right? I think they gave me an 8 there.
Yes.
Yeah, so what's got to go here then? 2. Right? Now it's up to you to figure out how to do these, right? So like, you got to be really careful about what you put here. So you know it could be 1, 5, and 9. So maybe this is a 1 and this is a 9. Why would I want to put a 9 here and a 1 there? That makes 15, right?
Yeah, but 8 plus 9
Ah,
is 2.
shit. See? So this could be systematic guess and check. So I just guessed something and I could see that it was wrong. So I'm going to improve my guess. Would this make more sense?
Yes.
Yes. Now what would have to go here to make 15?
6.
6. Now what would have to go here? 4. Yeah, I don't want to do the whole thing.
Yeah, you should do it.
No, you should do the whole thing.
No, I stopped. Alright, well, is everybody with me so far? Okay. Yes.
Can you go over B next, like the same problem?
Yeah, is B the one that wants to do multiplication?
Yeah.
Okay.
Well, you said, I just put 1s in all the boxes. You said it was wrong.
Of course it was wrong.
But they
No,
were
it's-
equal to 1.
What they want, sorry. The roll call note the numbers 1 through 9 will not work. Oh, so inherently what they meant was you have to use different numbers for every one, but I'll show you. Once you see the answer, you'll go, oh, of course, shit. Now, this could still be wrong, but because I wasn't really careful, but what would have to go here to make this work? What am I trying to add up to be? 15. So what do I have so far? So it has to be a 3, right? And thankfully I haven't used a 3 yet.
11.
So this would have to be what though?
7.
7, and I haven't used the 7 yet, so this is perfect. You're welcome. Now listen. The trick for part B, right? Did anybody think they got part B? What'd you do?
So I just tried my calculator like over and over. I ended up going with factors of 6, like multiples of 6.
So give me an example.
So like in the middle box, I tried 6, and then I can't remember what the actual like question was asking. I think I just multiplied like.
I'm with you.
Yeah, the middle box I said 6, and then like diagonally it was like 3, 6, 12.
Oh, okay, so 3, 6, 12?
Yeah.
Okay, and alright, let's just hear your whole box, let's see if it works.
Hold on. I show you. 'Cause I did it. Like, I did the diagonal the other way.
I see, okay. Alright, I see, yeah, you're right, it's a little weird to try to twist it. Alright, so then 18, 4, 1, 36, 12, 9, 2, okay. So let's see, 18 times 12, 18 times 12, this is 18 times 12, so that's the same. So one nifty thing is, if I do 18 times 12, that's the same thing as 9 times 2 times 12, which is the same thing as 9 times 24, for example. What did I just use? I took a factor away from 18 and I gave it to 12. Compensation, multiplicative, yeah, I appreciate you trying to get the whole thing out there. Multiplicative compensation, yes. This is the neat thing about factors. You can play around with them to get other factors, right? So that is one way to answer this, is to try to come up with a nice enough number. And 36 times 6 is 216, is that right? 216 is a nice number because there's a lot of different ways you can break it up. You can break it up as 18 times 12. You can break it up as 9 times 4 times 6. Because 18 is 9 times 2, 12 is 2 times 6, so 9 times 4 times 6. Do you see that? Okay. I love it. There's a simpler answer. And I love it. No, you did great. I need you to understand. You did great. I didn't think about that. Because the minute I thought about this other thing, I'm like, okay, that's all I can think about. Anybody else have another go? And you're all like, just show me the damn thing. So what if I just do this? This is almost what you did, but you have other factors in there too. What if I just do this?
Oh, okay.
Because if I multiply, I'm just going to add the powers. I already know that these numbers all add to 15. Therefore, these numbers are going to all multiply to be 2 to the 15th. That's the most direct way to do it. It's just the idea of, I know these add, so multiplying, how do I make it addition if I make it like bases with powers? Bam. But I need you to understand, that kicks ass. I like that. Brute force works sometimes too. I love it. Are you guys at all okay? Some of those problems are just try some shit out. And if I gave you that problem on a test and you just could not figure out the answer, don't erase your work. That's where you're gonna get all the points. Yeah.
It's another like kind of pattern one. It's 4.1A30. It's 99 times 36 and 99 times 30 and 23. There's apparently a pattern.
Oh yeah. Okay. So, all right, what'd you get for 99 times 36?
99 times 36 was 3564.
All right, let me catch it. So 99 times 36, 3564. What was the other one? 99 times
23.
23, what's that?
2277.
Okay. And then it said,
Then there's a pattern with 9 times.
look for a pattern, then predict. So they wanted to predict 99 times
57. and then
57,
63.
63. So is this enough to go on to figure out a pattern? No, you kind of hope, the first ones that you can see 3 and 6, you're like, okay, maybe it's that. No, shit, right? So that's not a good enough pattern. Let's do another one. What's 99 times 46? That'll be 4,554, right? So notice.
Yeah.
Does that help out?
Yeah, but it's the 99 times 23 that's confusing me a little bit.
All right, look, 23, 22, 36, 35, 46, 45. Right? Alright, now. So I would predict this to be what to start with? 56, okay. Now can we see a pattern for this guy? What's 54 plus 46? Compatible numbers. 54 plus 46? 100, that's right. 64 plus 36? 100. 77 plus 23? 100. So what would this be? No. What makes 100? 57 plus 43. Did anybody do 99 times 57? 99 times 57?
It's the 43.
Yeah, buddy. So that problem was evil because we almost always need at least 3 things to see a pattern. 2 things is almost never enough to see a pattern. Right? I mean, if I said 1, 2, what's the next number?
3.
No.
So,
It's not enough to go on. Are you with me? Do you guys see what I'm saying? I don't know what the next. It could be almost anything. You haven't given me enough. If I put this here, now we can kind of narrow it down a bit. Yes. What would the next number be?
9.
Now you're like, I don't want to say, Jeff. And to be honest, there's still a few options, but it would most likely be 8. It looks like I keep multiplying by 2. Is that cool? That was what I was thinking about. There's probably something else. So again, this problem is a little evil, and I'm sure you guys would agree that there are several problems that are full-blown evil. But you just had to do one more example. I think that just didn't give you enough examples to go off with. By the way, real quick, what's the quick way to multiply by 99? This is something we've talked about. Well, yeah, 99 is 100 minus 1, right? So here's how I did this shit in my head. 46 times 100 is 4600. Minus 46 is 4554. So that's why the pattern works, because 99 is almost 100. So I have 100 of these minus 1 of these. That's how I multiply by 99 really quickly. And that's when we can use distribution to kind of like do more complicated multiplication problems. Yes?
It's 3.1 set B, number 17. Because I figured out A and B, but then I was having a hard time with C.
No, honestly, I just skipped those.
Oh yeah. All right, let's put this up here because this one definitely gets weird. I don't know if I can ever get you guys to really believe me. You hit a problem with the homework, you try some stuff out, you're like, I really don't get this. Turn in what you tried. Because you're gonna want that shit from your students. How in the world can you help them get from where they are to where they need to be if you can't see where they are? That's what I need from you, and that's why you're gonna get, most of the points are gonna be just, show me what you're trying to do for these kind of problems, right? Okay. Sorry, it's number, is this one down here, right? Is that right? Which one was it again?
3.1 set B, number 17.
17, okay. So this guy. So it says, addition subtraction. The figure is completed by filling the upper 2 circles with the sums obtained by adding diagonally. All right, so that's easy enough. Right? And then it says, it even shows you, ooh, thank you, book. And it says the circle on the lower right is filled in one of 2 ways. Adding the numbers in the upper circles, or adding the numbers, adding across the rows, adding the blah, 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 right? So you can either add the numbers in the upper circles, so 13 plus 11, you put a 24 here, right? Or You can add down the columns and then add the results in each case, blah, blah. So just add all the numbers together. What do you get when you add up all these numbers? 9 plus 8 is, plus 3 is, plus 4 is, which is 13 plus 11. So on one level, I need you to understand that this is silly. 13 and 11, you've added 2 of the numbers at a time. If you add 13 and 11, isn't it the same shit as adding all of the numbers? That's all this thing is saying. That's all it's saying, guys. The hard part of this problem should be, and I understand that it could be the way they explain it. It could really look like, what the hell are they getting at? So here's the completed one there. So this one real quick, this one, what will we go here? 20, what will go here? 13, what will go here? Yeah, 20 plus 13, right? And they actually, okay, yeah. Now this one is kind of like, this one you have to think backwards, of course, right? And this is a decent little puzzle for a student. What is a student using to do this? Messing at it, I love it, right? 9 plus 1 is 13, so that's the first step towards subtraction, right? And students, little people, love a lot more shit than older people love. They will do stuff that older people, you gotta like pay them to do. It's crazy. So they are all about puzzles and so forth, especially when they get to show off something that they know. So are you with me on that? Okay. Now this number, what are you doing out there, number? Oh, I see, that's just the adding these things, okay. So they're getting a little more, so again, it would just be another missing adding going this way.
I just don't know where to start with part C though.
Yes, C is the one I think would be the
Yeah.
trouble. So what you do in this case is you fill in the middle blocks with A, B, C, D. If I fill in the middle blocks with A, B, C, D, see, do I have a blank one? No. So, you guys help me out. We'll do this one. Yeah, gimmit. Okay, stay. So anytime I want to use a variable instead of numbers, just wherever the hell you would normally put numbers, you just put variables. They might be different numbers, so you just put, in this case, I'm just going to put A, B, C, D. What's going to go in the circle here? A plus D. What's going to go in the circle here? C plus B. And then the circle here? Yeah, A plus D plus B plus C. And this would be A plus B, and this will be C plus D. So see, this is actually showing you associativity and commutativity, right? What was the question here? These are all showing some, okay. Sorry. So, if I don't care which way I go with this, if I add A and C and B and D, or if I add A and B and then C and D, I'm gonna get A plus B plus B plus C. No matter, it's just, and again, this is sort of illustrating that I don't care what order we add in. Addition is all on the same level in PEMDAS, so PEMDAS is like, whatever the hell you wanna do, buddy. That's why we're allowed to do compatible numbers, because I can just move them around. I can add whatever order I want to. Yeah. Is that all right? So I understand that one can get a little freaky. Whenever we bring variables in, things can get freaky. Not in a good way, sorry. Anything else from anything?
Where's special factors again?
I don't know. So one of them is 5. If I want to multiply by 5, I could just cut this in half and then add a 0, right? I remember the book said that. Yeah, special factors, they kind of shoved it at the bottom somewhere. Was it in 3.2, I think?
I'm getting it on a question on 4. 4.1b.
Oh.
4.
That was in 4. Oh yeah, 4 is the mental math stuff. So yeah, in this 4.1 section, they put stuff. Here, the very bottom here. Oops, sorry. Like 99 is considered a special factor because to do it, you can do it as this distribution like we did earlier, right? In fact, it's exactly the problem we did earlier. Yeah, division by 5, I've shown you that before. You just divide by, you just double the thing and then move the decimal back once.
What page are you on?
I'm just looking at special factors, the definition. So 4-1, number which one?
4.
This guy?
Yeah.
So 99 times 53, you do it exactly like we just did earlier.
Yeah.
It's 100 minus 1 times 53. 41, now what do you think about, okay, real quick. I desperately need you guys to understand this. Does everybody really understand the shortcut to dividing by 5? What's the answer? Give me the answer now. So the idea is if I multiply by 2, I get a 10 on the bottom, and then dividing by 10 is stupid easy. So the shortcut is double the number, move the decimal back once. If you double the number, so what's 144 divided by 5? Well, what's double 144?
288.
288. Move the decimal back once, I'm done. Kicks a lot of ass. And I know you have calculators, but I bet you I can beat your calculator in some of these. I'm not a human calculator. That's bullshit. Do you see something about part D? Part D is a little bit of a stretch, but you know, they try. What can I multiply 25 by so that it's a much nicer number to be on the bottom? I can multiply by 4. Now the silly thing is, the top, can you multiply the top by 4 in your head? I'm almost certain you could if you really tried. I need you to understand, why did I multiply this by 2? Because it makes it 10 on the bottom, that's a nice number. So here I'm going to multiply by 4 because it makes it 100 on the bottom. And then I'm going to move the decimal back twice because now I'm dividing by 100, not just 10. Well, what's 4 times 41? 25. What's 4 times 4? Holy shit, and then 4 times 100. 400, 4 times 25, another 100, so that's 500, yes? Did I do that right? I don't know anymore. Yes, okay, good job. And then I divide by 100, so bam, bam, 165. Crazy sauce. That's a stretch. Because it's a little harder to multiply certain numbers by 4 than just to double them. 5 I would definitely call a special factor. 25, it's a bit of a stretch when the top is really big.
Did we go over number 5 in practices?
Yeah.
Reduce.
So, what does your set have to contain in it? What numbers?
0, 1, 2.
Stop. No. Just to match, it must contain, the only thing it had to contain, say it had to contain was what numbers? No, come on. That contains the what? Additive identity and the multiplicative identity. What is the additive identity? 0. So one level of this problem is, do you remember what additive identity refers to? Identity means it doesn't change anything. Additive, so what do I add by to not change something? 0. Multiplicative identity. What do I multiply by to maintain something's identity? 1. Is everybody with me? So I'm trying to build a set. All I told you is it definitely must contain those two things. So it contains 0 and 1. I guess. Is that okay? Okay. So one level is you gotta remember where the hell identities reference. So in this case, 0 and 1. Do I need to add anything to make this closed under multiplication? Is this already closed under multiplication? What's 0 times 0? 0. What's 0 times 1? What's 1 times 1? Do I need anything else? No. If I put anything else in, then I'm going to screw myself over. Yes? So I'm not going to add anything. That's it. So this problem, several levels. What's the additivity? What's the multiplication? So put those in. Those have to be in. Then you step back and go, do I need to add anything? But you don't need to because you get only stuff in the set already. It's already closed. Does that make sense? So that sounds difficult, but you break it down. What is the additivity? 0. What's the multiplication? It's 1. Okay, it's got to be in there. Let me see if it's closed. If it isn't, what do I have to add? I don't have to add anything. Now, if I said it had to add the additivity, multiplication, and the number 2, how many things would you have to add? Is it closed under multiplication? No, because you get 2 times 2 is 4. The minute I do that, now I have to add 8. Yes? The minute I do that, so now what's a quick way to identify what those numbers are? I have to add all of the powers of 2, right? 2 squared, 2 cubed, 2 to the 4th. Yeah. So that, I didn't ask that question, correct? That's an example of something where you have to add some shit to make it closed. With a lot of sets, the minute you start adding anything, you sort of can't stop most of the time. Yes?
But I thought it was, doesn't it, I thought the question has to be, this is the additive identity and the multiple.
Yeah. Well, the additive identity is 0. So I'm sorry, that 2 I just added in.
Yeah.
So we already did the problem. So the additive identity is 0, and the multiplicative identity is 1. Do I need to add anything? Is it not already closed?
No, it is.
It is, so therefore that's the answer.
Okay.
Yeah. What's the smallest set that contains 0 and 1 that is closed under multiplication? 0 and 1. If I noticed, like I said, if I told you to put stuff and then you're like, oh shit, I get this, it's not, and then you have to add it. And then you have to add more. And then you're like, oh my god. Is that all right? Okay. You're all like, yeah, Jeff, you word your questions just as well as a book. Good job. That's right. I do like to make my own. I try to use test banks. Have you guys ever heard of test banks?
Yeah.
They suck so bad. So there are these things, and a lot of them nowadays you can just have an automatically populated test with stuff. Invariably, they suck some way or another. I don't know. I just like make my own prompts. All right. Anything else? We got the quiz you can ask from. We got homework. We got the test. You can ask general questions. Number 1. Is that which version did you have? Let's see. Oh, weird boxes.
Oh, that's the practice test.
Oh, the practice test. Okay. All right. Sorry. You said quiz, and I was like, I don't see it. Okay. Beautiful. This question I was talking about earlier with some people. What is the operation in that table? Huh? Addition. Good. And we know how addition works, right? Okay. Oh, it's over here. Just look at the table. Forget this question. Dumbass question, Jeff. Stop it. What is C plus B? Can anyone tell me what C plus B is? C plus B is B. You've done multiplication tables, addition tables in the homework. You need to know how to read them, right? Now, the hard part about this problem is 5C. What does 5C mean?
5C.
C plus C plus C. Well, what's C plus C?
C.
So what's C plus C plus C?
C.
So C plus C plus C. Yeah. Does everybody get what I just said? C plus C is C. So I don't care how many C's you add, you're always going to get C. So what can I replace 5C with? What does 5C equal? C. We do this again. Does everybody agree with me that 5C means C plus C plus C plus C plus C? Yes? What's C plus C? C plus C is C. What's C plus C? C. What's C plus C? C. What's C plus C? C. Okay, so 5C is C. So what does C seem to be acting like? It seems to be acting maybe a little bit like 0. 0 plus 0 plus 0 plus 0 plus 1, 5 times 0 is 0, 0. So so far I've got B plus, what is that? B plus C plus A, yes? In fact, you guys help me out. If I ask you to do 10 plus 3 times 2 plus 11, what would you do first? Sure, what would you do first? The very first thing you would do?
3 times 2.
3 times 2. What's the very first thing we did? 5 times C. What would you do next? 10 plus 6, yes?
Yeah.
What am I gonna do next? B plus C, because it's in the parentheses. What is B plus C? B plus C is B. And what's B plus A? B plus A is C. So for that problem, when in doubt, just say C. No. Is that better? So obviously, I know we all know how numbers work. So I need to go deeper than that somehow, but still keep it as addition. That is still addition. But I need to give you something a little bit freakier, just so we can get a little deeper than just surface level addition. We already know surface level addition. This is what your students are going to feel like when they are learning base 10 addition. They're going to feel like you feel on this problem. Yes? We don't remember that. I don't remember feeling that. I don't remember. But that's how I felt at some point. Yeah.
4.1 set B 9. What does it mean by when it says with adjustment?
Oh yeah, so, alright. This is my least favorite part of this section. Here's the, where'd the adjustment go? Blah, 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 blah. It's here somewhere. Where's the adjustment? This is in section 4.1, right?
Yes, it's
Yeah.
right there printed with adjustment.
Oh, here it is, okay. I thought it would be bolded. So all this says is the front end, literally just take the first, in this case, the hundreds place, right? The front number, the first digit. The adjustment is you just estimate for the rest of it. So 400 plus 200 is 600. 98 plus 51 is about 150. So then you get 750. So front end by itself just means kind of like the lower end of a range estimate. 400 plus 200. Just the first numbers you see. With adjustment means just average, not average, estimate whatever's left.
Okay.
Yeah. Okay. Yeah.
Look at mine, and so I can figure out, cause I have a hard time with like the 1 column, 2 column and adjustment, just cause I couldn't tell if I was rounding too early, or like, you know what I mean?
So which one is which?
Like, so that one's the adjustment one,
So this is, what's it say?
4,600 plus 8,100.
Okay. So then that will be front end with the, so is it 2 column with adjustment? So then you would do,
Okay.
is that what you're doing? 2 column with adjustment?
Can you get, or,
How's that? Let me see, what's the question say?
Estimate each of the following using 4 front-end methods: 1 column, range, 2 column, and adjustment. And with
Oh yeah, so the only one we talked about was front end with adjustment. So
okay,
let's see.
so.
And again,
we do like
like,
the
guys-
first digit.
Let me see. So this one here, yeah. Which, wait, is it number 9?
Yeah.
Okay. So like front end for this would be 1,000. Well, front end for this one would be a little weird because it would literally be 1,000. Because you only look at the first column, right? So front end, let me see if they gave us an example just to show you. They didn't really give us a lot of examples here. Blah, blah, blah. One column front end estimation method. So let's see if they go far enough. Yeah, here we go. So right here, but watch. 376 plus 53 plus 417. What's the very first, what's in the first column of each number? 3, 0, 4. See how they ignored the 50? Okay, so this one is really, really, really crazy.
Everything except.
Because what's in the first column of every number? 1, 0, 0, 0, yeah. So front end by itself is 1,000, which is obviously very wrong. 2 column will be much better, because then you take 15 plus 3 plus 5 plus 1. Is that, do you see that?
What if the 1,000, like, so on B, what if 1,500 wasn't there? Then
Yeah, if that wasn't there, then front end would be 3 plus 5 plus 1, it would be 900, would be the
two
estimate.
column would be like 340 plus.
34 plus 58, yeah, followed by 0, is that cool?
Okay.
Is the fact that that's there, so the front end would look at just the first column of digits, and the only one that's got 1 is 1 up there. Okay. Okay. Definitely a low estimate, right? Very low. Okay. Did that help? Okay. I am not gonna focus a lot on those. But you do have to try them for homework. Some of them don't make the most sense. The front end doesn't make very much sense when you have very different, all I gotta do is throw $1 million in there and then it doesn't matter what the hell anything else is. But that kinda makes sense. If it was $1 million plus what I have in my bank account, we have about $1 million, right? That's a really good estimate. You guys, you understand?
Yeah.
Yeah,
It's a good way to get rid of outliers.
Huh?
It's a,
Yeah, it's a way, yeah, yeah. Alright, that's all I'm gonna say, yes.
What's the rectangular array?
Ah, okay. So you got set method, which I think everybody should be cool with set method. You got the measurement model, right? Set model, I should use the right word. Set model, measurement model, which normally is like a number line. But the minute I start talking multiplication, I think about 2 dimensions, right? So if I do a rectangular array set model, or I do like, yeah. That would be like, if I had 2 times 3, that would be this. If I do rectangular array measurement model, that would be the ice cube tray, right? Is that right?
Yeah.
How would it be different if it was 3 times 2?
Maybe other way back.
Yeah, which is really cool, because physically it's the same shape, so numerically it should be the same number, which is really cool first step towards commutative property, right? Okay. Yes?
What about chocolate frequency section
20? Okay. Oh, yeah, thank the gods, okay.
Yeah.
Sorry. I keep forgetting this, to address this. I've seen so many of you guys doing some funkadelic stuff. Now, can you guys help me out? Is there anything repeated up here?
second number.
Isn't this repeated? Do you see how it's been distributed? So I'm gonna undistribute it. Right? It's like the uncola. I don't know if you guys are with me. So if I have a number, let's say 3 times 5 plus 7, wouldn't that be 5 times 3 plus 7 times 3? Can I do it like that? Okay. Then could I just take the 3 back out? Yes. Okay. So here, what number can I take back out?
The long.
7, 6, 5, 3, 2, 1, 4. So I can take this number, Jeff, out, and what's left?
234.
2, 3, 4, 8. plus 7652. Notice this, 9, 9, 9, 10. So therefore it's gonna be 10,000. These are compatible numbers, kind of big ones. I don't know if you guys are with me. No? Somebody just mouthed no. So how do I multiply this by 10,000? I just have to add 4 zeros, yeah. So that's how you do that problem. You notice that these are the same. Right? So then you just take them out. And what's left actually adds up to be a nice multiple of 10. This happens more than you know. So if I had to do 11 times 887 plus 9 times 887, I could just do 887 times 20. It's the same thing. 11 of these plus 9 of these is 20 of these, right? So 2348 of these plus 7652 of these is 10,000 of these. That's another way to look at it. Does that make sense? You don't have to like it, but give me an indication if that makes sense. I can tell you don't like it, but it needs some kind of a little like, oh, well that shit, or something. No? Yes? Okay. That was not the best example. When we get to fractions, I want to show you some cool shit, because I know people generally don't like fractions, but there's some cool shit related to this. Yeah.
Can we do the question 3 on this?
Yeah. Which one?
Question 3?
You have to make the table for it.
Yeah. Okay. So here's, did somebody come up with a way to do this directly, so you don't have to like do work on the side and so forth? Like the easiest ones to fill in are what?
The zeros and ones.
Yeah, so I'm not gonna, well, I mean, so this will be 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Whoop-de-doo. Now the neat thing is, when I go to the next one, I'm just gonna add 1 to each of these.
Yeah.
Does that make sense? The thing I gotta be careful about though, since it's base 7, if I add 2 things, then the answer would be 7.
You gotta make sure it's 10.
Yeah, I gotta make sure to represent it with the 1, 0. I like it. So then this will be 2, 3, 4, 5, 6, 10. Same thing here, right? So this is what we did earlier, where like I only had to worry about really half of it, because the minute I know this column, I know this row. So that's why I really kind of only have to worry about roughly half of this picture, right? Then, is everybody with me? If I do the next one, what happens?
4.
Now it's 4, 5, 6, 10, 11. Yeah, because I just keep adding 1. The trick is I roll over at 7 now instead of at 10. But then I just keep adding 1 on top of that afterwards, right? So it doesn't go far enough for me to get to 20, correct? So that's kind of nice. So I'm basically done with worrying about when this sucker's going to roll over, Jeff. Let me just show you exactly the wrong thing.
You're testing us.
Sure. Testing myself, and apparently I passed. And I failed. Alright. Is that alright for that one? So now it'll be 10, 11, 12, 10, 11, 12, 13. Yeah, okay. Now, real quick, is this section understood here? To make this quicker. Here, I'll give these out right now, basically, but let me show you this first. So here's the completed thing, and apparently Jeff had a little issue here, but too bad. So when I ask you 12 base 7 minus 4 base 7, what a student is going to do is they're going to use missing add-in. They're going to say, oh, here's a 12 that came from a 4, and it was put together with a 5. Okay, so 5 and 4 is 12, so therefore 12 minus 4 is 5. Okay. Don't say that to too many people. 12 minus 4 is 5, but we know it's based on. Okay. You guys all with me? So this one I just have to do the inside first, and then I do those two. Again, to do this problem, I would find 10. 10 that goes with 3. So I can see a lot of 10s on here, but I want a 10 that goes with 3. And then I say, oh, 3 and 4 make 10, so 10 minus 3 is 4 makes 7. Is that alright? That's how you kind of read that in reverse. So let me give you these. So you can all check my work. I tell you something. A teacher is another human being. You're all humans, right? I'm not gonna out you if you're not a human, but we're all humans. But it's really funny to me. I don't blame them. The students, like in that pre-calc, if I make a mistake on my answer key, oh, they're all over. I'm like, okay, all right. I'm excited for the day of the test. I might get to see some people I haven't seen in a while. You never know.
I was just thinking about that, cause when I was doing the practice test for that, I just did it a different way, a slightly different way. Where I took, for example, the 12 here, and I just went up. So eventually,
You went, you kind of like counted back. Oh, okay, so you did a takeaway.
Yeah.
All right, that'll work. So what she did was to do 12 base 7 minus 4 base 7, she found a 12, and then she went 1, 2, 3, 4. So that's the opposite of counting on. She counted back, so it's like the takeaway method. That's fine. Yeah. Yeah.
now I'm a little bit confused about number 2.
Oh, thank you.
Yeah,
That's why I was raising my hand.
I just thought that area was length times width, so I thought that it would be,
Yeah, but areas length times width is how I made this option. That's how I made this list, right? Where am I at? Here. Right?
yeah.
But then perimeter is how I'm gonna use the wood, yeah? That's how I'm gonna use.
Okay, so it's asking actually for.
Because I wanna know, in order to construct this shape, I've gotta fence in all 4 sides. That's perimeter, right? Yeah. So no matter what shape it takes, the point here was I wanted to have 72 square feet, right? If I remember correctly. Yeah, and there's multiple ways to have 72 square feet. More than likely, I would not want to do it the first way, because that would be 1 foot by 72 feet, which would give me 72 square feet. The very interesting thing, you guys notice what happens as my 2 dimensions get closer to each other. The required fencing goes down. So to maximize, to require the least amount of fencing to have the same area, the answer is always going to be a square.
Yeah.
But to really get down to it, you ready? What shape really minimizes the surface area, meaning the amount of material I need, is a cylinder. Especially if it's something, that's not rectangular. So if I had to fill it, so if you go through Georgia, I was born in Georgia, you'll see all these silos with all these peanuts in it, because we're kind of known for our peanuts. And they're all circular, these silos. They're all circular, because that's the least amount of surface area, the least amount of material to get the same amount of volume. If they used a big rectangular thing, they'd have to use more resources to build it. I don't know if you guys, this is beyond what we have to worry about, I'm sorry.
Yeah, do we even get to volume in this?
No, yeah. Maybe. I think we do. No. That's all a side note, I'm sorry. Yeah.
4.2, number 20, in step 8.
24, 220. Here. Set A, sorry. Yeah, set. This one here? Sorry, this one.
Yeah.
Okay. So 27 times 33. So I showed you how to kind of like line them up next to each other. So you would represent, how would you represent 27? I would represent 27 in base 10 blocks. 27. Yeah. How many of these? 2. And then 7 blocks, right? And then I would have for 33, it would be 3 of these. And then 3 blocks, right? So then here, it would be 1, and then you keep going, right? Does that make sense? The nice thing is you can just know ahead of time what 27 times 33 is supposed to be, and you can see if you're headed in the right direction, right? This is a rectangular array method with base 10 pieces. Do you see that? So like here, it would be, it's gotta be the same width there and the same length there. Okay. It's so funny because I use the same soundtrack to go to sleep to.
Literally just record that and just.
So on the test, I'm not gonna be as specific as 20B. When you're doing your homework, you can look up intermediate algorithm 1. I'm not gonna make you memorize what intermediate algorithm 1 is. Right? You can look that up. So we talked about the evolution of the idea of multiplying and how we eventually get to a standard algorithm. But in the homework, you can just look and see what that is. No? Yes?
You know number 14, that's the estimate one? Like, is that when we changed, like, the numbers again?
Yeah, so that one, so I don't tell you to estimate any certain way, do I? So what I really want is what we talked about. If I make one part go down, another part's gotta go up, right? So if I make this become 20, then I can make both of these become 50 and 10, right? So 20 times 50 times 10 is easy to do in the head. Does that make sense?
Yeah.
Okay. So I didn't ask for a range estimate or anything, I just want you to estimate. So the idea of estimating multiplication, if I make part of it go down, something else has to go up. So that overall it comes out to be the same product, right? So like what's 4 times 5? 20 is crazy. What's 2 times 10? 20. Holy shit. So 4 times 5, if we make that go down to 2 and that go up to 10, it's still the same product. So the idea with estimation, if I want to estimate multiplication, if I make one number go down, another number's got to go up. And then it should roughly come out to be the same thing. Range estimation says, screw all that, just make everything down and everything up and it's somewhere in the middle. Is that okay? Alright.
So then we're estimating 1,000?
Yeah, we're just trying to figure out roughly what that is. So if I do 20 times 50 times 10, I'll be close. And if I ever ask you an estimation question, do something and then do it on the calculator. Make sure that you should come out close, right? Yeah. Yeah.
When you're asking for the range, and
you find the low and high, so you want the average of those two?
No,
or
no, no,
just the low and high?
if I just ask for the range, you just give me the low and the high.
Okay.
I just wanted to let you guys know, a natural next step would be to average the two, to get a decent estimate, right? But that's not a part of the process, yeah.
And to average the two, you would just add them up with black ones, right?
What's the other question about the
Oh, yeah. So multiplicative compensation, that means I'm gonna take a factor from one, give it to the other. So what do I wish to make 5 become? 10. So can you take a factor of 2 from 212? Did I do something weird on my answer key?
Anything with 1 of 6.
No, I did fine. Yeah. Right, what's half of 212? Yeah, 106, so then I give that 2 to 5, so now it's 106 times 10, and that's easy. Multiply by 10 kicks ass. Did 13 go okay? What's the idea with that? Number 13. Keep subtracting until you have less than what you're trying to subtract left, right? So I'm gonna keep subtracting 60, and then I just kinda count how many times did I subtract 60. That's really crazy, and some of us have lost touch until you took this class. You lost touch with the fact that's what division is. You don't think of division as repeated subtraction. Why would we? Because we developed these other algorithms, but it's really good to remember that's all this stuff is. It's just repeated subtraction. Why does that make sense? Because division is the opposite of multiplication, which is repeated addition. So of course division should be repeated subtraction, right? Yes?
What would you do if you're dividing 3 divided by 7?
Divide what, sorry?
3 divided by 7, if you're dividing something bigger, so you can always subtract.
Oh, so it would go in 0 times, right? Alright, so, so if I do 3 into 7, right? No, 7 into 3. 7 into 3, so I go in 0 times. So what's the remainder? 3, yeah. And again, the remainder is how much more there is. Well, what's 0 divided by 7? 0 divided by almost anything is 0. So how much more is this than something that 7 would go into evenly? It's 3 more. That's why there's a remainder of 3. It's how much excess there is. How you guys feeling right now? Is there anything else that's still an issue? You're like, yeah. There's a few things.
Wait, I'm sorry. The little exponent on the bottom, what does that mean?
Where are we at? Oh, the base?
Okay, never mind.
Okay. Okay.
Right, okay.
That was neat. The way you said that, I had to take a minute.
That,
The little
that
excellent.
confused me for a second.
Okay. I don't blame you.
Explain what you just did again with the,
Which one was it? Oh, here.
that from version 2, you said you.
Yeah, it was from the homework. I remember this. So we just do what we always do every time we do this. So like 6 into 15 would go twice with 3 left over, right?
Right.
Whatever's here is what's left over. So if I do 7 into 3, it goes 0 times with 3 left over.
Okay.
Yeah.
Right. Okay, that makes sense.
Yeah, the process can't change. wanna check in with you guys, does everybody really understand how my office hours work? I'm in my office sometimes, but I have office hours in different classrooms also. I don't know if anybody's noticed, I've sometimes had people from other classes come in, they normally hover over here. Cause this is before this class starts, it's my office hours, right? So you can certainly come to any of those office hours in a classroom before my class starts. And if you wanna stay and like watch that class, you could out here. I don't know if you want to, you're like, I got enough shit to do, Johnny. But those are also office hours, those are open to anybody.
Count 5.
Huh?
Watch you teach count 5.
Count 5.
Be like writing magic on the board.
Yeah, because calculus only goes up to 4, right?
Well, depends how you define things. I always say calculus goes to 3. And then you start going into different subjects. You can call all kinds of things calculus 4, calculus 5. But it doesn't make sense to me because it goes beyond that. It's even better than furniture motion.
I don't even know what calculus is. A friend tried to explain it to me once and I was lost.
Calculus is what fixes your brain first.
No.
Yeah.
I love calculus, yes?
So the test is gonna cover 3.1 through what, 5.2?
So it is 3-1 through, no, we haven't done any of 5 yet.
It's 4.
4.
So you.
3-1.
It was 1.2 chapter.
Yes,
chapter
just a
four.
minute, let me catch up. So it's definitely 3-1 through 4-2, but also 1-2, because we didn't have 1-2 in the last one. So I already told you guys I'm gonna have one problem from 1-2, it's gonna be, something about finding a fact. Yes.
Is the lattice method gonna be on the
Lattice method was from, which section?
4.2?
4 point what? Oh man, did I miss lattice? I love lattice. I totally missed lattice.
All I can think about is
Oh, real quick.
pi.
Alright, I'm not gonna, that sucks, man. I totally missed lattice. Lattice kicks so much ass. Tomato and lattice, alright. So the lattice method is really kind of nifty. So if I wanted to add 141 to, geez, it's been too long. Shoot, I need to get ready for this. Lattice method. Because there's a lattice method for multiplication and there's a lattice method for addition. And I missed both of them because I suck. Let's see.
You're fine.
Where was the addition one? No. Oh yeah, thank you. I'll get it. Oh, there it is. Okay, good. Okay. So make sure. I thought I was in a different section, but obviously I was wrong. All right. So really quickly, I won't put this on the what do you call it? So if I want to add 141 to 327. The idea is, so I construct this table. Let me put a problem up here so you guys can see a better representation of the table. Alright. Oh shit, did not do that. Alright, so there's the look of it, right? So, I'm gonna make this one's kind of easy. Let me make something a little more interesting. So if I have to do 57, so it'll be 1, 2, that's 12. 5 and 7 is 12. 4 and 2 is 06. 1 and 3 is 04. 2, 7, 4. 2, 7, 4. Do you see? Huh?
I've learned this before.
Okay. Do you see how the carry the 1 sort of just happens? Because I put the 1 up there and I do diagonally, the 1 ended up going over, because how would we add this directly? Wouldn't I put a 2, carry a 1, right? Yes?
Yeah.
And when I put 12, and I treat this as if it's the next step, the 1 carried over with the 6, didn't it? The 1 carried over with the 4 plus 2. Yeah. This is kind of nifty. I can't believe I missed that. Damn it. So there's been a lot going on, let me just say. Some of it I told you about, and some of it I haven't told you about, so I've been a little bit of all over the place. So yeah, I missed my lattice method, but is that okay? You guys see how that's not that terrible? Yes, it's kinda nifty, cause carrying the one, you don't have to think about it, it just naturally happens. I'm not saying I've seen lattice method used in a lot of different places, but it is a process you can use. It's not like a step before just carrying the one. You just point out, after you do several of these, you just point out to students, couldn't we just put a 2 and put a 1? That's basically what this is. I mean, you can do it after a while, right? Okay. Man, I'm really bummed out. I love the lattice method. There's a lattice method for multiplication, but do what you can with the homework. I'm not gonna, maybe I'll put a bonus one on there on the test. Yeah.
Is there gonna be a bonus sheet on this exam?
Yeah, every test they get bonus questions, including the final. There's gonna be some final exam bonus questions.
You sure that's one multiplication?
Yeah, let's see if I remember how to do it. Multiplication is a little different. You have to set it up. Let me see if I remember. So let's say I want to do something not too crazy. 123 times 31. I think you have to set it up like this. Is this right? Shit. Let me look at it. I feel like that's right, but it's weird. Oh shoot, where'd it go? Where are you? It's just wait a minute. Where did you go? There it is. Okay. It's kind of like an afterthought in the book even, but look at this. So this one was, let me make sure I put things in the right place. I probably did. Okay, 35 times 49, so it's on the other side, okay. That's the part I couldn't remember. So if I want to do 123 times 31, 3 times 3 is 9, 2 times 3 is 6, 1 times 3 is 3, 3 times 1 is 3, 2 times 1 is 2, and 1 times 1 is 1. So let's see if we get this right. 3, now here's where this one kind of cheats a little bit. 9 and 2 is 11, so I have to carry the 1 still. 8, 3. What is 123 times 31?
3813.
Sweet, okay. I didn't like the multiplication one as much because you actually have to do your own carrying of the 1. It doesn't really come out in the process. If you add these and it's bigger than 10, then, you know, you're gonna have to carry it yourself, but, okay. The addition one's a lot more interesting, yeah. Multiplication just gets messy, I wouldn't. That's why in the book, it's sort of like an afterthought, and I don't blame, it's just a lot. Yes, no, maybe so. And I'm sure you guys have all seen the, like, 3 times 2. Have you guys all seen this? 1, 2, 3, 4, 5, 6. It's 6, right? Like maybe I'll make a bonus question about why that's true. Real quick, do you see the connection between this and if I do 3 times 2? You see there's a connection? Instead of counting the crossings, I count these. Jeff, if I would just count 2 right, that would be great. There we go. Then it would come out right. Okay. So there's a connection between rectangular array method and this counting the crossings method. All right. I brought nothing, by the way. It's all up to you. If you have no more questions, we're done. Okay, if you
I
have
think
more
our brains are dead.
questions, if you actually have more questions, come by office hours. If my office hours don't work, just email me. You can email me questions or you can email me with times you'll be on campus.
I can tell you if I'm also on campus, right?
Email you at like 2 a.m.
Huh?
Email you at like 2 a.m.
Yeah, you can email whatever the hell time, because I'm not gonna see it until I'm up. Who
You
gives a
seem
shit?
like the
I love when
type-
people email, I'm sorry it's so late, I'm like,
You seem like the type of
How would
guy
I
that
know?
would respond to an email at 2 a.m.
You do.
I could, yeah. Sometimes I can't sleep and I'm doing stuff, it's like, come on, Jack. Maybe I'm playing Skyrim, I don't know.
I got 'em.
Skyrim.
I'm actually going through my first playthrough.